So the last part of this that we need to do is solving rational and then solving absolute value equations. Okay. So when we solved the fraction equation in the previous part of this, we always found the common denominator and multiplied through by the common denominator. When you're solving any rational equation, that same process is what we're going to use. So it says here we're going to multiply all terms by the common denominator. So you have to be careful and make sure that you're multiplying everything by that common denominator. So here's our first example. So first of all, we have to look, we have two different denominators. We have a denominator of 5 and a denominator of 2. So we need to find our common denominator. What would our common denominator be between 5 and 2?
10.
10. So we're going to multiply everything through here by 10. Okay. So I am going to write this out. If you can skip this step, you can do that. But sometimes it's easier for some people to see it if I write it out. One thing that you have to make sure also is that you're multiplying that 10 times the 5. That's a very common mistake. So we would have a 50 over here. Okay. So if you were to simplify this, we're going to take the 10 and divide it by 5, which is going to give me a 2. So we'd have 2 times y minus 3. And then a 5 times y plus 4 equals our 50. Do our distributive properties. So we'd have 2y minus 6 plus 5y plus 20 equals 50. Combine our like terms. So we would have a 7y plus 14 equals our 50. We're going to subtract our 14 from both sides. We'd have 7y equals 36. Divide both sides by 7 and we get y is 36 over 7. Now, we have one solution. When you have one solution, we called it conditional. So this would be a conditional equation with a solution of 36 over 7. Questions on anything on that one? Again, if you feel like you can skip this very first part, that's okay. Skip it. I know as of right now, all your homework and quizzes are online, but eventually when we're taking regular tests, you will have to show your work because I will be looking for that. Okay, so we're going to go ahead and go on to the next example. This one's a little harder because it doesn't have just numerical values in the denominator. We actually have some expressions. So what we have to do is any of them that can be factored, your first step is to go ahead and factor them. So this last one that says x squared plus or x squared minus 9, it's our difference of squares, so we can actually factor that. And it does factor to x plus 3 and x minus 3. Now, when we're finding our common denominator, when we looked at the last one, we had 5 and 2, so we found a common denominator of 10. Here we're looking for each factor, just like 5 and 2 were factors, we have to look for our factors here as well. So our first term only really has one factor, and that factor is x minus 3. So we have to use that as part of what we're going to multiply. That's part of our common denominator. If we look at the second one, we have x plus 3. That also has to be part of our common denominator that we're looking for. If we look at the last piece, notice it has both of them, but we already have both of them, so we do not need to add another one. So we're going to have our x minus 3 and our x plus 3 would be our common denominator for that entire piece. When we multiply through by that common denominator, again, I'm going to write this entire step out. If it is something that you do not need or you can skip, you can do that as well. But I would have x minus 3, x plus 3, all over x minus 3, minus x minus 3, x plus 3. Again, you would have all of that on the top, but we have a 6 here as well. So we're going to have 6 times x minus 3, x plus 3. I've got a lag in my pen, so I don't know what's happening. And then we have our x plus 3, x minus 3 on the bottom. Now, the reason why I did want to write this out, at least for this time, is so that you can see that things will cancel. So we have an x minus 3 and an x minus 3 in that first piece, and you can cancel those. In the second piece, we have an x plus 3 and x plus 3 that can cancel as well. On the last one, it's really nice because all of the x plus 3, x minus 3s will go away. You have to be very careful here. On this first part, we're going to have the x plus 3. On the next one, because that's a negative there, I'm going to put the negative, but then I'm going to put the x minus 3 in parentheses. You will need to do that. If you don't do that, then you're going to have a mistake, a sign error. So, and that would equal 6. Now, we have to distribute that negative through. Distributing a negative through is really switching your signs or multiplying through by a -1. So we'd have x plus 3 minus x, and then plus 3 equals 6. So the x and the negative x will cancel out. So we have 6 equals 6. So 6 equals 6. What does that mean?
All answers are correct.
Say that differently.
Infinite.
Infinite. It does have infinite solutions. Does that mean that all real solutions would work? What do you think? Will every number work for x?
Yes.
Yeah. What do you think? There's actually a couple that won't work. What are they? What are numbers that we say it has infinite solutions? It does have infinite solutions, but there are a couple numbers that will not work. What numbers?
3,
3 and
-3.
-3. So when they do the solutions on this, and you'll see this on the web work, it will say something like this. It'll give you a set bracket and it'll say X. Then it'll be a vertical line. So that means X such that. So this vertical line means the word such that. Okay. X cannot equal 3 or -3. So it means all x's such that x is not 3 or -3. So that's the notation that they will use for that. So I know there's a question on the homework that pertain to that. And a lot of it, we're picking identity, which yes, it has infinite solutions, but it does have some restrictions because we cannot have 0 in that denominator. On the next one, we're looking again for our common denominator. This time we only have one term in the denominator. So our common denominator here is going to be an x plus 6. The common mistake that's found here is when you have these just constants, people forget to multiply the constants by that common denominator. So you need to be careful. Again, I'm going to write everything out. So I'm going to say x times x plus 6 over x plus 6 plus 3 times x plus 6 equals 1 times x plus 6 minus 6 times x plus 6 over x plus 6. Again, you're going to cancel what you can cancel. And then do some distributive property, combine like terms. So we're going to leave this x here. And then we're going to do our distributive property, which is going to give me a 3x plus 18. And we're going to have x plus 6, but then over here we still have a minus 6. Combining our like terms, we have 4x plus 18 equals x. Subtract 4x. So I have 18 equals a -3x. X would be a -6. Now, are we finished?
No,
Why not?
because you need to divide the 3 over.
Oh, well, I did that. I just did it over there.
Oh my gosh, I didn't see that.
That's
never
okay.
mind.
So we have x is -6. But can -6 work?
No, because your denominator would be 0.
Correct. We can't plug it in. It's not going to work. So we have to make sure that we check solutions. So when we check the solution, we plug that in, we get 0 in the denominator. Does anybody know what that's called when we have an answer, but it doesn't actually work? It's an extraneous solution. So really this problem has no solution. And it is inconsistent. Oops. Okay, so there's no solution and inconsistent. We have to check our solutions anytime you're solving a rational equation. Questions on this problem? So here's our next one. Again, we can multiply by the common denominator, or what's another approach that we could do with this one?
Could you multiply the right side by 2?
You wouldn't want to multiply by 2, but we could just think of it in terms of just cross multiply. Okay. So really what we're doing is we're taking our y plus 1, or sorry, y minus 1. Y is I'm having some issues. I'm going to stop share for just a second. I apologize. All right, let's see if I can get it to work now. There we go. All right, so we would have y minus 1 times y minus 2 equals y plus 1 times y plus 4. So we are going to do some distributive property. We're going to take y times y, which is going to give me a y squared. Y times a negative 2 is a negative 2y. Negative 1 times y is negative 1y. And negative 1 times negative 2 is going to give me a positive 2. Then we would have y squared plus 4y plus 1y plus 4. Now it looks like we're going to be solving a quadratic equation. However, it's kind of nice because we have y squareds on both sides. We can just subtract that and those will go away. So we're back to just a linear equation. So we have negative 3y plus 2 equals 5y plus 4. It doesn't matter what side, we're going to move that 5y over. We'd have a negative 8y. Subtract our 2 would be equal to 2. Divide both sides by a negative 8. And we get y is a negative 1/4 if we reduce. Now in this case, is negative 1/4 if we're checking our solution going to work? Yes, no? Does it make either denominator equal to 0?
No, it doesn't.
No, so we're good. That is our solution. We have one solution, so we call it conditional. Okay. So now what we're going to do, so that's our rational. We're going to get into some absolute value. This first absolute value is fairly easy. Remember when we're talking about absolute value, we're talking about the distance something is from 0. So in this equation, we're saying, okay, I want any x's that are 8 units or have a distance of 8 from 0. So we could be at 8 or we could be at negative 8. So when you're solving an absolute value equation, you will be solving 2 equations. You would have x equals 8 and x equals negative 8. So your first equation will be exactly what's written without the absolute value. Your second equation, you're going to take whatever's in the absolute value, you leave that alone, and you switch the sign on the opposite side. So here's another one. This time it's not just x in the inside, but it doesn't matter. You're still going to set up 2 equations. We're going to have x minus 4 equals 8. And x minus 4 equals, and then we switch the sign on the 8, so we'd say negative 8. So again, just make sure anytime you're solving an absolute value, you're solving two separate equations. We're going to add 4 to both sides. And we'd have x equals 12. And x equals a negative 4. So again, make sure you're writing out two equations when you're solving absolute value. This one works the same way. We still have to solve two equations. We would have 3x plus 4 equals 12, and 3x plus 4 equals a negative 12. Subtract our 4 from both sides, and then divide by 3. Same thing on the right side, subtract your 4 from both sides. We get 3x equals a negative 16. Divide by 3 and we get negative 16 over 3. Please make sure that if you can reduce the fractions, that you reduce them, because that's what it'll be asking for in web work, will be the reduced answer. Questions on the absolute value so far? All right, now this one looks a little bit different. In order to write your two equations, your absolute value must be isolated. So it has to be all by itself. So that is the first steps on this one. You can't just start out writing your two separate equations. You have to isolate the absolute value. So we're gonna add 10 to both sides. We'd have 2 absolute value of x plus 5 equals 10. Again, our absolute value is not totally isolated. We still have this 2, so I would go ahead and divide by 2. We have absolute value of x plus 5 equals 5. Now we're to the point where you can set up your two different equations. We'd have x plus 5 equals 5, and x plus 5 equals a negative 5. Solve each question individually. So we'd have x equals 0 and x equals a negative 10. So again, when you're solving these absolute value, make sure you're isolating the absolute value part first, and then write your two separate equations. This one, again, is a similar type question. We have 2 absolute value of x plus 7 equals 6. Again, we have to isolate our absolute value. So we're going to subtract 7. We'd have 2 absolute value of x equals a negative 1. Divide by 2. We get absolute value of x equals a negative 1. Now, on this one, why would I tell you that there's a problem?
It's already negative.
It's negative. So can an absolute value ever equal a negative number?
No.
No. So in this case, there is no solution. And we called it inconsistent. Okay, so there'd be no solution and it's inconsistent. So this should get you through everything that you need for that section 1.1, that first lesson. Okay. The video is posted for the first part of the lesson, and I will post this video later today if you need to go back and look at something. Remember that the due date is on Friday for that homework assignment.